When I think about the age of the animals, I think, well, the young animals, they need protein, so their feeds, they are more proportionally, they have more nitrogen, they have more crude protein in that, and those crude protein, they will be lower at the finished level. So the proportion of those nutrients are different, but the amount, the volume of manure that's being produced at the finishing phase is greater. So there are a lot of things that we need to consider when we are dealing with manure. There is a great variability. It always depends what we are feeding the animals.
Welcome to the Swine Canada podcast show, brought to you by Wisenetics. We are dedicated to bringing you the latest insights and discussions in the Canadian pork industry. I'm Miranda Smith, and I'll be the host for today's episode. And today's guest is Dr. Felipe Hickmann, and we're going to talk today about nutritional strategies to optimize biogas production. But before we get started on that, Felipe, can you first introduce yourself a little bit and like what your interests are?
Thanks for having me. My name is Felipe. I'm originally from Brazil. I was born and raised in a pig farm, so I always got involved with pigs. And for my research, I was studying some nutritional strategies to mitigate the emissions from pig production. So we have performed some systematic reviews over the past 5 years or so, and we consistently found that feeding is the greatest environmental impact source associated with pig production, because it's not only about feeding, but also what is needed to prepare those feeds. So also the transportation. And besides feeding, there is also manure management. It's another great source of environmental impact. So my PhD was focused on those two main things. So what are the interactions between feeding and manure management? So today I selected one of our projects that was related more about biogas generation at lower temperatures. I think it's more suited for Canada because Canada has a cold climate, with cold has been updated since I went to Canada. My definition of cold changed a little bit. So what we were looking at was some anaerobic digestion of pig manure at lower temperatures, so that are more suited for Canada. So that's the overall topic that I want to discuss today.
Wisenetics turns podcast airtime into brand authority. We don't sell ads, we elevate voices. Curious how far your voice can go to become a reference in the industry and attract more leads? Scan the QR code and discover how we can turn your expertise into unmatched brand authority. Let's transform expertise into influence, starting now.
Okay, perfect. So can we first start a little bit by talking about what is biogas production? I mean, I think we all know that there's gas in manure, but how do you capture that, and what are some of the things that you need to consider when doing that?
Yeah, that's a good question. But first, I would go step a little bit back and talk a little bit about manure. So what we consider as manure. So what would be a good definition? Because sometimes people think, oh, manure is the feces, but not necessarily only the feces. There is some urine, there is some wasted water, some wasted feed. So manure is a little bit complex. So when we think as a fertilizer source, we have like a great variability, and also by the age of the animals. So when you look, like for example here, we have one nursery pig and one finishing pig. So how do you think about those manure composition? They are the same? They change over time? What would you think about manure composition?
Well, I assume that it's going to be a little bit different because the diets are different in nursery pigs versus grow finish. That's my guess.
The absolute correct. Because when I think about the age of the animals, I think, well, the young animals, they need protein, so their feeds, they are more proportionally, they have more nitrogen, they have more crude protein in that, and those crude protein, they will be lower at the finished level. So the proportion of those nutrients are different, but the amount, the volume of manure that's being produced at the finishing phase is greater. So there are a lot of things that we need to consider when we are dealing with manure. There is a great variability. It always depends what we are feeding the animals. It will also change the composition. The other thing about manure is hard to get to assign a value for manure. Because, for example, the mineral fertilizer, the cost, they skyrocketed over the last 10 years. So the manure as fertilizer, it's becoming like a hot topic, because instead of using urea or other mineral sources, we can also use manure. But besides the fertilizer, we can also produce energy from those manures, that's from biogas. So it's also another hot topic over the last years. And but biogas is not only biogas; it's a mix of gases. So when you think about biogas, you need to think about methane. You need to think about CO2. You need to think other uh, gases as well. So I was interested in looking to optimize biogas generation from pig manure. So when we look at biogas generation, we usually want to focus on methane production. So usually when the greater methane content of the biogas, the better. So for example, there is some strategies of biomethanization, for example, to increase the proportion of methane in biogas. For example, here, if you look, let's suppose this is a biogas molecule, the greater proportion would be methane. But there's another gases, so CO2 and H2S. Our idea is to increase the methane content, so one part. And this is a very interesting strategy to mitigate greenhouse gas emissions, because instead of releasing those methane that are in manure, we can use for energy. And so there is like a circularity aspects of when we are dealing with anaerobic digestion. So anaerobic digestion is like black box you put in those digester, but sometimes you don't know what you are getting out of it, because it really depends what you are putting in. So about anaerobic digestion, we are talking about biogas. So what would be anaerobic digestion? It's like I don't want to put some really hard questions, but it's a way that some microbes, they use the dry matter content of, for example, manure or on other things for their use. So they are using those molecules. For example, here we have a molecule that has different content. So different bacteria will we needed to break down those molecules. And when they break down those molecules, they produce biogas. But that those biogas, they change a little bit in terms of content. So my goal was to have a look what would be the impact of feeding. So using different feeding strategies to optimize the biogas generation. In a Canadian context, that's more like colder, because usually when we are working with anaerobic digestion, we are working at mesophilic temperatures. For example, 36 degrees Celsius would be like an optimal temperature for bacteria, but it's a little bit hot. We were trying something around 20 degrees, so it's a little bit lower. Of course, the digestion rate is not as fast as at mesophilic rates, but it's still possible. One thing of concern that when we are dealing of those type of projects is about ammonia inhibition. Because when you think about manure, you need probably think about the nitrogen content, but also ammonia. And for those bacteria that are doing the anaerobic digestion, ammonia may inhibit the process. So if you have a lot of ammonia, they will not break down those molecules and you don't have like a fast digestion. So there are a lot of things that we need to consider when we are doing those types of projects. So what is the best temperature? What are the feedstock that you are using? What's the composition? And so there are a lot of things that we need to consider when doing those type of projects.
Okay. And so it sounds like in your PhD, you looked at some of those ways to reduce the ammonia. Is that correct?
Well, not only ammonia, because we were doing some different projects. Some projects more related with feeding, for example, enzymes. So how can we use enzymes to mitigate the environmental impact? So we have looked at phytase, beta-manganase. There are some projects also with precision feeding. So some projects were related about the feeding phase or the animal phase, and other projects focus more on the manure part. So what will be the interaction, what was fed and the manure composition and how we handle those manures. So we have one big project that was related with lowering crude protein in diets, also in pigs and but also in poultry. And what would be the impact of using those manure? So one project apart was focused on ammonia volatilization, because when you think as manure as a fertilizer source, we want that the manure, the nutrient that is inside, will go to the plants. But sometimes it's tricky. We have some part of the nitrogen will be lost through ammonia volatilization. There is potentially some runoffs. So those manure that are applied, sometimes we have like we lose some nutrients, and also some difference between organic sources and inorganic sources. For example, urea. When you apply urea, you design our application rate that's suited for that growing season. So we applied what the plants they need for that period of time. But when you are working with manure, sometimes it's not so easy because those nutrients, they will not be released as fast as we wanted. So probably when you apply manure, it will go around 2 or 3 years for that manure to be digested for all the microbes that are in the soil. So it will be because we have interaction of the organic fraction in the inorganic fraction. Because the plants, they only use the inorganic form of the nutrient. But so instead of for going from the organic source to the inorganic source, we need the action for some microbes that are in the soils, and sometimes it takes some time. So yeah, so this was another project that we were looking at what would be the impact of using those manure. So one aspect is using as a fertilizer source. So what's the amount that we are losing through ammonia volatilization? So from what we are applying, what we are losing through ammonia volatilization. And the other project was also for greenhouse gas emissions. So ammonia is not a greenhouse gas, but it's also important because it's also a pollutant for air quality and so on. So usually we also look, besides ammonia, we also do look at methane, CO2, and N2O. Those four main gases, there are the main gases that we look when we are working with manure. But let's get back to the topic that's about biogas generation. So when we look at those biogas projects, we were trying to work with animals that receive low crude protein diets. So when you receive a lower crude protein diet, what's your expectation for the nitrogen content in manure?
It'll be lower.
Yeah, exactly. So if you look at the literature, around 8 to 10% of reduction for 1% of crude protein that was reduced in the feeds. So if you are lowering the crude protein, probably you are reducing the manure, the nitrogen in the manure. I say probably because sometimes things are a little bit tricky. Because go back to our different pigs. So do you think that the impact for the nursery phase will be similar to the finishing phase, or perhaps no? You have any guess?
Well, my guess is going to be no, but I don't actually know why.
That's a good start, I would say, but it always depends how much you are reducing in the feeds. Because what we saw in our experiments, because we have the control diets, we have a reduction on 1.2% and another reduction of 2.4%. But sometimes for nursery pigs or younger animals, they need more nitrogen. If you are reducing too much nitrogen, they will increase the feed intake to compensate those reductions. So in that case, they receive less nitrogen, but to compensate it, they eat more feed, so they have more nitrogen in the manure. But if you look at the finishing phase, usually the literature is very consistent. So if you are reducing the crude protein in the diet, we are also reducing the nitrogen content in the manure. So sometimes it's tricky because you don't know if you are reducing too much, because you need to pay attention to what are the animal requirements. Because if you are reducing too much of the crude protein, you may affect other things. So yeah, that's one thing that we were surprised, but not so surprised, because it's a fair effect, I would say. So the first thing would be, what would be the impact of manure composition. The other thing, if you think about environmental impacts, is about animal performance, because we also run life cycle assessment. We doing other projects as well. But when you look at environmental impact assessment, you are usually looking at the amount of resources that are needed for a given output. So, for example, if I need more resources to produce the same quantity of meat, you are increasing the environmental impact. So, performance is very important when we are assessing the environmental impact. So, when we let's focus again or reducing the crude protein. So if you are affecting performance, we are also affecting the environmental impacts. So some studies, they already look at this. More than 90% of the environmental impact would be associated with the performance of the animals. One, because feeding has the greatest environmental impact. And if you are affecting performance, you are affecting the resources that are needed for a given output. So when you are looking at nutritional strategies to mitigate emissions, you need to look at what will be the impact on the animal performance and what will be the environmental outcomes, for example, manure composition. So we have the animal phase. Now let's discuss the trials with the manure, because biogas is our topic today. So we split in different treatments with different nitrogen concentrations. So we have three, so the control, the low nitrogen, and the very low nitrogen. And those biogas generation, they will assess it every day, and the biogas composition 3 times per week. But when we are working with biogas generation, we need to analyze the data from different perspectives, I would say. Because remember when I was mentioning about the dry matter content, the bacteria. The dry matter content is very important for bacteria because it's their food. If you don't have food for them, they will not produce biogas. So usually when we are assessing biogas generation, we start also monitoring the volatile solids content because it's the amount of food that we are providing for bacteria. So this experiment, it was around 1 year, and we developed different cycles. What it would be one cycle? So at the time that we feed the manure in those digesters, so we have a lot of food for the bacteria, so they are producing a lot of biogas. But over time, they will use all those molecules and they will start reducing the production of biogas. So then we need to start another cycle, putting more manure inside the digesters. So that will be another cycle. So we consider another cycle when we reach 10% of the total volatile solids that were given at the beginning. So we have like an estimation about what would be the potential to produce biogas. So that's another way to look at the data because you can, so you have the biogas generation for treatment, but those treatment, they have different solid contents. So in the paper, we did the analysis in two different ways. One way would be divided by the amount of volume that was used, for example, for the control, for the low nitrogen, and for the very low nitrogen. And the other thing that we can analyze the data is based on the amount of solids that was provided in those digesters. So if you look at these different ways of analyzing the data, if you analyze the data based on volume, there was some difference in treatments, but they were very low. But at the time that we analyze the data based on the solid contents, we can see greater difference between treatments because that's what is needed for the bacteria to develop. So yeah, that's an interesting thing. You can analyze the data from different ways based on the solid contents. So usually when we are working with a reduction on crude protein levels, we are also seeing a reduction in solids in the manure. So there are different things that we need to consider when we are working with a given feeding strategy. So a little bit about the experiment. So we were working in different cycles, so around 13 cycles overall.
And how long were the cycles?
Around 21 days was like the time that was needed for the bacteria to digest all the manure that was given for that cycle. But also we're also changing the organic loading rate content. What would be the organic loading rate content? The amount that manure that we are adding each time. So at the beginning, we were a little bit afraid because, okay, maybe if you give too much ammonia, it will be a problem for the digestion. But in the end, it was not a problem. So we could increase, and the system didn't crash. So over time, you also increase the amount of manure that was being added every cycle. So if you look at the results, we saw bigger difference between treatments when we were increasing the amount of organic loading rate. It makes sense because then we were increasing the amount of manure that was given at each given cycle. We are also increasing the difference between solid contents. So every time that we were putting more and more manure, we were seeing more and more difference in treatments. Okay, so that's another way of looking at. About the biogas quality that was generated, because usually when we start the cycle, the is around 40% of methane of the biogas is methane. And in the end, we will reach sometimes 60-65% of methane content. So usually as time progresses, we are seeing an increase also in the methane composition. So over time, you also see an increase in the quality of the biogas that's being generated. So there are a lot of things that are changing as we were changing the amount of manure, and we are changing the number of cycles. And so one thing, we need to think anaerobic digestion for a circularity system, because we can generate energy from those manure. But also we have the digestate. So we produce the energy that will be used for electricity, and then you can use for a different purpose. But you need also to use the digestate, the result of the anaerobic digestion. You still need to get to dispose at some point. You need to handle what you are doing with those digestate. And what we saw with the digestate is that it has a lot of nutrients. The form is more stable. We have lower odor, so it's good, because when you think about pigs, is sometimes a little bit challenging. However, there is one pollution swamp that's very important, is the ammonia content that in this digestate. So why this? I would say, why do you think that there is more ammonia content in the digestate compared to raw manure? Because it always depends on the action of the bacteria, the microbes. Because we have the organic form, and they will degrade and give the inorganic form for plants or for so on. And when we are moving from an organic form to inorganic form, you are also increasing the ammonia content that's more prone, the nitrogen that's more prone to volatilization. So you need to use some strategies to mitigate these ammonia emissions. So if you compare raw manure and digestate, the digestate has a good quantity of nutrients, but there is some possibility of losing the nitrogen through ammonia volatilization. So you need to use some strategies, manure management strategies, to mitigate these emissions. So timing is very important. And if you are incorporating this manure, is another thing. Because let's say if you apply in the soil, and I applied, and there is a great chance of losing the nitrogen to ammonia volatilization. But if you're trying to incorporate in the soil, you are losing that volatilization. So that nitrogen will go to ammonia, and will be in an inorganic form that could be used for plants. So you can use different strategies. When you are working with urea, so let's compare now urea and manure. Let's talk about the benefits of using manure, because we compare some experiments. What would be the impact of using manure and using urea? Because urea is an inorganic form, and if you have an inorganic form, you have much more chances of losing through ammonia volatilization. So it's a big problem. Some companies, they already sell the urea with ammonia inhibitors. So it's another way that you pay more, but you lose less ammonia. But I will just give you some numbers. When we were applying manure, we lost nitrogen to ammonia volatilization. Only 4% of the nitrogen was applied to manure was lost to ammonia volatilization. But if we were applying to the urea, we lost around 20-25%. So it's a good thing to apply manure. You are losing less, but not all those nitrogen will be readily available because it will take some time to the microbes to digest. So there are a lot of things you need to consider when we are working with type of projects.
Yeah, it sounds like it sounds like it's actually a lot more complicated manure than I thought. I thought manure is manure, but you've cleared that up. It's a lot different than that. So is there anything else, like when it comes to biogas production in like the lower temperatures, like the Canadian climate, that you need to consider versus, warmer climates? Like what would be the biggest difference there?
Yeah, that's a good question. So the experiment that we developed was at psychrophilic temperature around 20 degrees. It's not optimal to biogas generation, but it's reasonable. It's not the same digestion rate. There is not the same stability. It's a little bit lower. So things takes more time to get digested. So, but sometimes when you don't have a lot of organic loading rate to add, you don't have a lot of manure, it could be still possible. So it really depends what are the conditions of a given place, a given farm. So what is the amount of manure that they have to add in those digesters. So there are a lot of things that you need to consider. For example, the hydraulic rotation time is greater. So the amount of time that you need to put in the digestion and stay there is greater if you think about mesophilic conditions. So there are some things that we need to change in those digesters to adapt for a climate as Canada, for example, or something that is developed at lower temperatures. Low temperature is good because you don't have a lot of energy that you need to use to heat up the system to put like a 36 degrees. So you are saving some costs on that, but you don't have like as much as digestion as fast as you wanted. So there are some trade-offs when you are working with lower temperatures. So the thing is you need to adapt for what you want and for what you have.
So would you recommend producers to look into starting their own biogas production?
That's a good question. Sometimes it's hard to start like a biogas plant without assistance. And sometimes those biogas plants were developed for mesophilic conditions. So this is like a more research area for now at lower temperature, but I think it's still possible. Some farmers, they can start already work with a smaller digester. Doesn't need to be like a big one. You can start playing around with some trials to see what you get from what you have. So I would say the answer for your question, it depends. So it depends how much knowledge you have on the subject as well.
Okay, well, so thank you so much for joining me today on the Swine Canada podcast show.
Thank you.
Okay, so that concludes another episode of the Swine Canada podcast show presented by Wisenetics. So thanks everyone for joining us today. Don't forget to subscribe to the podcast to stay updated on future episodes. So this is Miranda Smith from the Swine Canada podcast show signing off. Until next time.